Welcome back, viewers. As I promised in the last lecture, today in this lecture, we shall do more of exercises. And my hope is that these exercises will help us drive home some of the things we've learned so far. I will start with the easy ones and try to move up in the kind of hierarchy of difficulties. Let us look at some exercises that involve absolute value function. Let us start with the following. Number one, if we recall, remember that when we introduced the absolute value function, at somewhere we made this as one of the properties of absolute value function, and I left it as an exercise for listeners to try. Now let us try to see if we can do justice to this. And the idea behind this is so simple. It's just a matter of considering several cases, and we'll be done. Here I'll say to achieve, to prove this, or rather to get what we want, the following cases arise. The following cases arise. Case one, here will require that suppose x, y are both greater or equal to 0. If x, y are greater or equal to 0, then x times y will also be greater or equal to 0, because product of two non-negative numbers is also non-negative. We have therefore that absolute value of x here will be equal to x. Let us recall that absolute value of x is equal to x if x is greater or equal to 0, and minus x if x is less than 0. We recall this. So for the fact that x, y greater or equal to 0, then absolute value of x will be x. Absolute value of y will also be y. And the absolute value of x times y will be equal to xy. That is x times y, because x times y is non-negative. And this is the same thing. This we can therefore write as equal to, since absolute value of x is x and absolute value of y is y. So we can write this as absolute value of x times absolute value of y. So if x is greater or equal to 0 and y is greater or equal to 0, then absolute value of x times y is equal to absolute value of x times absolute value of y. So in this case, what we are looking for is trivially true. Now then look at we now consider case 2. Case 2 is the case we assume that here we assume that x is less than 0 and y is greater or equal to 0. If x is less than 0 and y is greater or equal to 0, then in this case, absolute value of x will be equal to minus x, and absolute value of y will be equal to minus y. Will be equal to y, because y is greater than or equal to 0. So absolute value of y will be equal to y. Now, what happens to x times y? You see that we observe that x, y will be less or equal to 0. Because since y is greater or equal to 0 and x is less than 0, the product will be less or equal to 0. And if the product is less or equal to 0, this is equivalent to xy is less than 0, xy is less than 0, or xy is equal to 0. Now, if xy is less than 0, this will only happen, then it means that then this implies that y is truly bigger than 0, so that absolute value of x, y will be equal to minus xy, and this will be the same thing as minus x times y. And this is nothing but, since x is less than 0, we see that absolute value of x is minus x. And since y is bigger than 0, we see that absolute value of y is equal to y. So this minus x here will turn out to be absolute value of x. Why this y here will turn out to be absolute value of y. And this will therefore give me that thing is equal to absolute value of x times absolute value of y. That is the case when x, y is less than 0. If x, y equals 0, then the only reason why this will happen is that this will imply, this implies that y is equal to 0. Remember where I'm getting this from. Remember we are assuming that y is greater or equal to 0. So y greater or equal to 0 means that y is either really greater than 0 or y equals 0. So if we have that the product of x and y is equal to 0, what this is, x is really positive, it's really negative, what it means that y must be what? Must be 0. And in this case, we have therefore that, therefore, absolute value of x, y will be equal to absolute value of 0. And this we know is equal to 0. And this 0 we can write as if I like 0 is 0, and anything, since 0 is 0, I can write this as minus x times 0. It's still meaningful. But what is minus x? Minus x will turn out to be absolute value of x. And this 0 here will turn out to be y. So this will be, this we can say right as minus x times y. And minus x is what? Is absolute value of x. Y is absolute value of y. The reason is because absolute value of 0 is equal to 0. So again, we have that absolute value of x, y is equal to absolute value of x times absolute value of y. So in a case where x is really less than 0 and y is greater or equal to 0, we'll get that absolute value of xy is equal to absolute value of x times absolute value of y. Now, a similar case, there's no need repeating it. I should have called it case 3, but that is the case where x will be greater or equal to 0 and y will be really less than 0. But you find out that the whole case will reduce to repeating always almost the same thing. But in that particular case, we have to interchange the role of x and y. We have to interchange the role of x and y. That's the case where we assume x is greater or equal to 0, while y is less than 0. So what I will now consider as case 3, which is the last case, is the case where we assume that x is really less than 0 and y is really less than 0. If we take up this case, what we'll get here is that here, absolute value of x is equal to minus x, and the absolute value of y is equal to minus y. Again, we should know that for the fact that x is less than 0 and y is less than 0, we'll get that xy will be, of course, bigger than 0. xy is bigger than 0, so that absolute value of xy will be the same thing as xy. for this xy is the same thing as minus x times minus y, because minus minus will cancel out. And minus x is nothing but absolute value of x, since x is less than 0. Y minus y is absolute value of y, since y is less than 0. So this will turn out to again give us absolute value of x times absolute value of y. So what we have is therefore that in the case where x is less than 0 and y is less than 0, absolute value of x times y will give us absolute value of x times absolute value of y. So from what we've seen already, we'll see that having covered all the possibilities, remember that the fourth possibility would have been where we interchange the role of x and y here. That is assuming that x is greater or equal to 0 and y is less than 0. But it will be a repetition. And you remember that all these variables are dummy variables. So it doesn't matter. This case covers the case I'm talking about. Now, having gotten all these things, we can conclude therefore, hence, for any x, y we pick in the set of real numbers, absolute value of x times y is equal to absolute value of x times absolute value of y. Absolute value of x times y is equal to absolute value of x times absolute value of y. Now, let us look at another exercise. Let me call this one exercise number 2. Is less than minus 2. Say, when this kind of thing comes, one should recall that the place where we have this kind of inequality, we require that m, for instance, will be greater or equal to 0. And in that particular case, we're taking x in R, we had that absolute value of x less or equal to m is equivalent to minus m is less or equal to x less or equal to m. Or we can say absolute value of x is really less than m is equivalent to minus m is really less than x, really less than m. For this to happen, we must have that m is greater or equal to 0. So having this, somebody may make a mistake of trying to apply this formula. This particular thing as a formula will not make sense here. It will not make sense because I've seen a situation whereby some students will go and start applying this, seeing m as minus 2. No, this is wrong because looking at this, the property of absolute value, one of the properties of absolute value function has already shown us that this particular thing is bigger or equal to 0. That is absolute value of x plus 5 is bigger or equal to 0. And since it's bigger or equal to 0, if we insert 0 before, we'll get that this inequality will imply that 0 is really less than minus 2, which is a contradiction. And this therefore means that telling us to find the values of x plus 5, find the values of x, so that absolute value of x plus 5 is less than or equal to minus 2, leads to something that doesn't make sense. And this means that the values of x for which this will happen in R is empty. That is the collection of x for which this will happen. That particular collection must be what? Must be an empty set. So what let me, so just to formalize things, I may put here that absolute value of x plus 5 less than minus 2 is contradictory since from the property of absolute value, since from the property of absolute value function, we know that for any x in R, absolute value of x is greater or equal to 0. Thus, we have in particular that absolute value of x plus 5 is greater or equal to 0. Therefore, if we put 0 less or equal to absolute value of x plus 5, assuming that this is possible, I will now have that this will be less than minus 2. This inequality will imply that 0 is really less than minus 2, which is a contradiction. A contradiction. A contradiction. It's a contradiction. Therefore, so the set of values of x in R such that absolute value of x plus 5 is less than minus 2 is empty. Is empty. So what are we saying? The set of values of x in R so that absolute value of x plus 5 is less than minus 2 is empty. That is the collection x in R so that absolute value of x plus 5 is less than minus 2. This collection is an empty set. It's empty. Now, we proceed to yet another exercise. Question now is, what can we put on absolute value of x minus x naught and the absolute value of y minus y naught, so that absolute value of xy minus x naught y naught will be less than epsilon. Let us see how we can answer this question. I'll put here answer to the question. We estimate now. Observe that for any xy we pick in R, absolute value of xy minus x naught y naught will be equal to absolute value of xy. Here, we'll start playing some algebraic tricks. And we must do it in such a way that these two entities must come out. And then when these two entities comes out from our estimate, we will now see what we may be able to do in order that we make this happen. So I think this is what we should watch out for and see how it's done. This kind of exercise, I'm intentionally bringing it up now so that at least people will see how certain elementary manipulations are made, and this can lead to certain conclusions. So we look at this. This will be, here I would look at this minus x, say x y naught, then plus x y naught, then minus x naught y naught. You see, what I did was to remove x y naught and then add again x y naught, meaning that I have not distorted the given the initial expression, because this will still cancel out this to give me back this. So this will give me nothing but, observe that having done this, this will give me absolute value of x into y minus y naught. Then plus here I'll have y naught into x minus x naught. And then by the property of absolute value, we can get that this is less than or equal to absolute value of x into y minus y naught plus absolute value of y naught into x minus x naught. And this, we know, is equal to, please, what we use here, what we made use of here, is the fact that we know from our previous lecture on absolute value that absolute value of x plus y is less or equal to absolute value of x plus absolute value of y, what we call the triangle inequality. Now, at this point, I'll make use of the first exercise we just did, that absolute value of x times y is equal to absolute value of x times absolute value of y. And this will give me, therefore, that this is equal to absolute value of x times absolute value of y minus y naught plus absolute value of y naught times absolute value of x minus x naught. Let me label here 1. Now, remember that y naught is fixed and y naught and x naught are fixed. So in this computation, we'll be seeing y naught, or rather x naught and y naught as constants. So they are fixed. So the varying values are x and y. So all the values that are varying must be controlled in order that we'll be able to get what we are looking for. So this particular absolute value of x, I can see the x there as a varying value, and therefore we must put it under control. I would like us to observe that absolute value of x is equal to absolute value of x minus x naught plus x naught. And this is less or equal to absolute value of x minus x naught plus absolute value of x naught. Thus, if absolute value of x minus x naught is less than 1, say, I'm using 1 for simplicity. Any person, we can use any constant, but for simplicity, if we assume that absolute value of x minus x naught is less than 1, then let me label here 2. Then from 2, we shall get that absolute value of x will be less or equal to absolute value of x minus x naught plus absolute value of x naught. And this will be strictly less than 1 plus absolute value of x naught. So what we've gotten here is therefore that absolute value of x is still less than 1 plus absolute value of x naught whenever absolute value of x minus x naught is less than 1. So this is the first control we are putting on absolute value of x minus x naught. As we move further, we shall see whether there will be another further control on absolute value of x minus x naught. Maybe I call this 3. Now, using 3 in 1 gives, using 3 in 1 gives absolute value of xy minus x naught y naught. It's less than. So what does it mean? This means that if I come in 1, this particular absolute value of x we are seeing here will be controlled by this. So if I use this inequality in 1, I'll get that absolute value of xy minus x naught y naught will be strictly less than 1 plus absolute value of x naught, replacing that absolute value of x above, then times y minus y naught, then plus absolute value of y naught times absolute value of x minus x naught. So this is what we've gotten. So remember, what we got is that absolute value of xy minus x naught y naught will be still less than 1 plus absolute value of x naught, and then into times absolute value of y minus y naught, then plus absolute value of y naught times absolute value of x minus x naught. This is what we have. So let me maybe still label here, say 4. So next, to get further control on the absolute value of y minus y naught, we must be looking at this inequality with a guide us. And the factor that is multiplying the entity we are to control will also play a role. That is this factor. And also this factor will also play a role. And we must remember that we are giving epsilon bigger than 0, and our requirement is that this must be less than epsilon. So what we should do now to get it done is looking at what is before us. We will see that if absolute value of y minus y naught is less than that epsilon over 2 into 1 plus absolute value of x naught, and then absolute value of x minus x naught is less than epsilon over 2 into 1 plus absolute value of y naught. If we do this, if we put this control on absolute value of y minus y naught and the absolute value of x minus x naught, we shall, if this happens, then we shall obtain from 4 that absolute value of xy minus x naught y naught will be less than 1 plus absolute value of x naught, then absolute value of y minus y naught plus absolute value of y naught, then absolute value of x minus x naught. And this will go further be less than absolute value of 1 plus absolute value of x naught in bracket times the control we placed on this is what is bringing this inequality. And when we bring in that control, I have here epsilon over 2 into 1 plus absolute value of x naught. Then plus, here I have absolute value of y naught. Then times, I have epsilon over 2 into 1 plus absolute value of y naught. So this is what we will get. And this will give us nothing but epsilon over 2 times 1 plus absolute value of x naught all over 1 plus absolute value of x naught. Then plus epsilon over 2 times absolute value of y naught all over 1 plus absolute value of y naught. Now here, something interesting is happening. Observe that this entity, these we cancel out. That is absolute value, 1 plus absolute value of x naught over 1 plus absolute value of x naught. This entity will give us nothing but 1. Whereas this entity, which is absolute value of y naught over 1 plus absolute value of y naught, is strictly less than 1. And this means, therefore, that we have, therefore, with this condition, absolute value of xy minus x naught y naught is less than epsilon over 2 times 1, of course, then plus epsilon over 2 times 1. So, and this is nothing but epsilon. So, let us remember. So, what I want us to remember is the following. So, absolute value of xy minus x naught y naught will be less than epsilon, is less than epsilon, provided 1 absolute value of x minus x naught is less than 1. That's the first condition we placed. And 2, absolute value of x minus x naught is less than epsilon over 1 plus absolute value of y naught. Then 3, absolute value of y minus y naught is less than epsilon over 1 plus absolute value of x naught. These are the 3 conditions, 3 controls we place on absolute value of x minus x naught as well as the absolute value of y minus y naught before we could get that absolute value of xy minus x naught y naught is less than epsilon. But the first 2 controls these 2 must be satisfied by absolute value of x minus x naught before we can get it. So to combine these 2, so we can now summarize by saying therefore that absolute value of xy minus x naught y naught will be less than epsilon provided absolute value of x minus x naught is less than the minimum of 1 and then epsilon over 1 plus absolute value of y naught. And then absolute value of y minus y naught is less than epsilon over 1 plus absolute value of x naught. So these are the required controls on absolute value of x minus x naught and absolute value of y minus y naught to make this happen. So for us to make this happen, we must require that absolute value of x minus x naught must be less than the minimum of 1 and this, and that absolute value of y minus y naught must be less than epsilon over absolute value of 1 plus absolute value of x naught. Please, at this particular thing, the estimate we get here, I must point out that they are not unique. They are not unique in the sense that everything depends on how whoever is handling this problem starts. If you look at what I did, you'll recall that I started with by adding x, y naught plus x, y naught. I removed this and added this, then before I have minus x naught, y naught. So another person may decide to look at x, y, then you have y x naught, then plus y x naught, then minus x naught, minus, then minus x naught, y naught. You will observe that this particular one is what led us this far. Somebody who is using this particular one who may have the estimates here, sort of the rule changing, in the sense that here, rather than controlling, if I go further with this, you'll find out that this will give me absolute value of y into x minus x naught, then plus here I have x naught into y minus y naught. Meaning that instead of controlling x as we did in this particular place, what this person will aim at is first controlling y. And in that case, it means that that person will have this number 1 in terms of y. That is here, the person will expect to get y minus y naught less than 1, and y minus y naught less than epsilon over. The rows will change. You have something like 1 plus x naught here, absolute value x naught here, whereas this place will be x naught minus y naught. So it depends on how the individual starts. And there's another thing I would like to point out here, which is very, very important. Look at here. Here is the place where some people may fall into trouble. If you look at here, you find out that I mentioned that the factor, that is the coefficient of this thing, will play a role. And the role it played is that it's this coefficient that enabled me to get this estimate for absolute value of y minus y naught. But even in bringing in the role of this particular coefficient, one must be very, very careful. Here, I just got this because looking at this, you see, I just put epsilon over 2 times this. Looking at this, I left it like this because I know that this can never be 0 because of this addition of 1. And that is why I have epsilon over 2 into 1 plus this. So this will not put me in trouble because this will never be 0. But here, nothing stops me from writing absolute value of x minus x naught less than epsilon over 2 absolute value of y naught. But if I do that, y naught we are given, y naught was just fixed in R. And that y naught was not restricted in the sense that we are not told that y naught is not equal to 0. Y naught is any fixed point, it is any fixed value in R. So it could be 0. And to avoid getting into trouble, instead of using y naught here, I had to add 1 to it. The essence of adding 1 to it is to make sure that this denominator is not 0, so that this thing will be well defined. And I have this. But interestingly, in getting down here, you'll find out that by the time you bring it in, then this value over this will give us something that is less than 1. Something that is less than 1. This particular case, I don't have a problem because this is already non-zero, and this is non-zero, and therefore they will cancel out to give us 1. So this means that if we go further, what we may even get further is that here, if I may fix it here, we'll get that this is actually less than epsilon over 2 plus epsilon over 2. I'm getting this less than epsilon over 2, this inequality, because this particular thing is really less than 1. Maybe I'll put it inside the bracket so that it will not be as if I'm saying that the entire thing is less than 1. So what I want to be, what we have as less than 1 is what is inside our circle. So this is what is less than 1. And that's why I put it inside the circle. So that inside the circle is less than 1. It's less than 1. This is less than 1. So that's it. So this is less than 1. If we use the fact that it's less than 1, we'll get this done. So you've seen that to put the condition on to control absolute value of x minus x naught and absolute value of y minus y naught, one must be very, very careful. I'm intentionally bringing up these things so that by the time they will start playing roles for us, we will not find them difficult to manipulate. Now let me do yet another exercise. Now the question is, what so that absolute value of 1 over y minus 1 over y naught will be less than epsilon. So this is another question we should answer in a moment, and we go straight to give an answer to that. We again estimate as follows. Observe that absolute value of 1 over y minus 1 over y naught is equal to absolute value of, here I'll find the LCM, and the LCM is y naught. Then if we evaluate this, will give us y naught minus y. So we have absolute value of this. And this we know is the same thing as absolute value of y minus y naught all over absolute value of y, absolute value of y naught, using this fact. Using this fact, and the fact that absolute value of the product is equal to the product of the absolute values. So we get this. Now, you observe that here, y naught is fixed. Y naught is fixed. Y is varying in R. So, as I said, whichever variable that is varying, that is not fixed, we must control it. So we really need to control this y in the denominator. So if we control it, then we will not think about going further to control this. But controlling this, you'll find out that the kind of trick I played above will must come to help us. Now, let me label here, say 1, and I'll say, observe that absolute value of y Okay, let me do this. Now, if absolute value of y minus y naught is less than, say, absolute value of y naught over 2, you will see the reason for what I'm doing now. If I put this control on absolute value of y minus y naught, if I do this, then we record the following property. Then absolute value of y minus absolute value of y naught will be, remember, is less or equal to absolute value of y minus y naught. And this is less than absolute value of y naught over 2. This means therefore that minus absolute value of, this implies therefore that minus absolute value of y naught over 2 will be less than absolute value of y minus absolute value of y naught, and which is less than absolute value of y naught over 2. Why is this coming? This thing implies, remember that this implies that absolute value of y minus absolute value of y naught in absolute value will be less than absolute value of y naught over 2. This is true. So, if this is true, we observe that this is a non-negative entity, that absolute value of y naught over 2 is greater or equal to 0. So, this brings us to the form absolute value of, say, x less or equal to m, where m is greater or equal to 0. Where m is greater or equal to 0. So you remember that this is equivalent to minus m is less or equal to x less or equal to m. Using this, that is what I use here. Since absolute value of y minus absolute value of y naught is less than absolute value of y naught over 2, what this implies is that this particular inequality is equivalent to minus absolute value of y naught over 2 is less than absolute value of y minus absolute value of y naught, which in turn is less than absolute value of y naught over 2, seeing this as our m. Now, having got this, what this means, therefore, is that we can add this entity to all true. If I add absolute value of y naught all true, I will get that this will now become, adding absolute value of y naught to this will give me absolute value of y naught over 2 will be less than absolute value of y, which is less than 3 absolute value of y naught all over 2. But my interest is in controlling this absolute value of y in the denominator. So what we have me control is so that this thing will be controlled by a constant, maybe depending on the y node. Then that is the word I will use. And from the inequality before, this particular inequality, you'll find out that the left-hand side of the inequality will do the job for us. And again, interestingly, absolute y naught is not equal to 0, meaning that this particular entity here is greater than 0. And for that reason, what this inequality, what the last inequality implies is that this inequality will imply that this implies that absolute value of y naught over 2 is less than absolute value of y, and which in turn, which is actually equivalent to, this one is equivalent to 1 over absolute value of y is less than 2 over absolute value of y naught. So absolute value of y naught over 2 less than absolute value of y is equivalent to 1 over absolute value of y is less than 2 over absolute value of y naught. Just take reciprocal. And using this in using this estimate in full, sorry, using this estimate in 1 as this okay, let me even call here instead of 1 so that there will be no so many ones. Let me call it star, for clarity's sake. Using this estimate in star gives the following. What it will give us is that absolute value of 1 over y minus 1 over y naught will be, we computed it to be equal to absolute value of y minus y naught all over absolute value of y, absolute value of y naught. This is what we got. And now that we've controlled this 1 over, this is still equal to absolute value of y minus y naught all over absolute value of y naught, then times 1 over absolute value of y. But this 1 over absolute value of y is controlled by 2 over absolute value of y naught. So we'll now get that this is less than absolute value of y minus y naught all over absolute value of y naught all over absolute value of y naught, then times 2 over absolute value of y naught. And this will give us nothing but 2 absolute value of y minus y naught all over absolute value of y naught all squared. So this is what we've gotten so far. Now, moving further, we'll again see that further, if absolute value of y minus y naught is less than, this is where I'll bring in the epsilon that will enable us to get what we are looking for. If absolute value of y minus y naught is less than, watch here, what I have here is 2 times absolute value of y minus y naught all over absolute value of y minus y naught all squared. Now, I want the whole of here to be replaced with epsilon. So what do I need to do? I have here, I don't have problem with y naught here because the absolute y naught is not 0. Therefore, absolute value of y naught is really bigger than 0, meaning that this square is bigger than 0. This is 2. So this is what we must manage in order to bring in that epsilon we are looking for. So to manage these two factors, this factor must play a role. And how do I use those factors? I will require that absolute value of y naught, y minus y naught, will be less than epsilon absolute value of y naught squared all over 2. If I do this, if I have this, then watch what is guiding me. The factor of absolute value of y minus y naught is guiding me in this construction. I introduce epsilon here because of what I'm looking for, what I want to get. So if I have this, then absolute value of 1 over y minus 1 over y naught will be less than, I have 2 absolute value of y minus y naught all over absolute value of y naught all squared. And this is now less than 2 over absolute value of y naught all squared, then times epsilon absolute value of y naught all squared all over 2. This is coming from this control on y minus y naught. And you observe that, of course, these 2 will cancel these 2. And this y naught squared will cancel this absolute value of y naught squared. So we have, therefore, that absolute value of 1 over y minus 1 over y naught is less than epsilon. But provided that 1 absolute value of y minus y naught is less than absolute value of y naught over 2. That's the first condition I placed above. This is it here. That's the first condition, or first control we place on absolute value of y minus y naught. And 2, we must have that absolute value of y minus y naught must be less than epsilon absolute value of y naught all squared over 2. That is the second condition here. So putting these 2 together, because these 2 must be satisfied before we can get that this happens. So what must happen? What must we do to get that these two are satisfied at the same time? So what we do, what we have is therefore that absolute value of 1 over y minus 1 over y naught. This thing will be less than epsilon provided that absolute value of y minus y naught is less than the minimum of absolute value of y naught over 2, comma, epsilon absolute value of y naught squared over 2. So if absolute value of y naught is less than the minimum of these two, then what that means is that absolute value of y naught is less than both of them. And that is how this particular thing will give us that these two are satisfied. Because since it's less than the minimum is the smallest. If it is less than the smallest of the two, it's automatically less than the biggest of the two. So it must be less than the two. So for us to get that absolute value of 1 over y minus 1 over y naught is less than epsilon, then we must have that this control must be placed on y minus y naught. The viewers may not really know why I'm doing this, but I'm preparing ground for what will come in near future, especially when we consider the concept of continuous functions. We may be required to prove that something like a function f of y, the f defined by f of y equals 1 over y is a continuous function. And in that case, if one has gone through this rigor at this stage, at that particular point in time, that person will no longer find it very difficult to follow the computation that will come up, which will more or less be almost what I have done now. And again, this brings me to a point where I will remind the viewers that doing exercises is very, very important. And I must point it out now that as far from my experience, I've realized that every exercise is like a formula for a problem that is coming in future. Every exercise is like a formula. In fact, it's a formula for a problem that is coming in future. Because if in the future you find out that you cannot do anything without falling back to already existing fact, and therefore I urge us to continue doing exercises, do as much as possible. And again, doing exercises allows us the chance to practice what we think we know. It's when you try to apply what you've learned in doing exercises that you will know the extent of knowledge you've gathered. So that if you're still finding it, that is experiencing difficulties in doing things, you may resort back to learn that thing further and come back to apply. Now, let me try to do another one, which is still in line with what we are discussing above. This time around, I will call this one exercise 5. Now, I'll ask the kind of questions I've asked above. I'll ask what control. So this is a question which you endeavor to answer now, and I'll go straight to the answer to that question. Again, we'll do the following estimate. I'll start by looking at absolute value of x over y minus x naught over y naught. Of course, even though I didn't mention it earlier, in where we assume that y naught is not equal to 0, but it's good we mention it now. You can see it's because of this quotient we have here that will require that y will not be 0, so that this particular thing would make meaning. And also, y naught is not 0, so that this particular quotient will make meaning. So when we are putting up an hypothesis, we are putting up conditions that will allow whatever we are trying to do to make sense. So now, let us try to estimate. This particular thing is, of course, equal to absolute value of what I'll do is to find the LCM. And here, LCM is y naught. And if we now simplify, you'll find out that this will give me x y naught minus y x naught. And this is equal to, observe that this is equal to absolute value of x y naught minus y x naught is the same as x naught y, all over absolute value of y, absolute value of y naught. Again, you see that this y has put in his head again and must be controlled. So I will mimic what I did above to put a control on this. And to be able to control it, I will have that, let me label here, say small a. Small a. So if absolute value of y, if absolute value of y, let me put it right. If absolute value of y minus y naught is less than absolute value of y naught over 2, as I estimated above, we'll get that okay, let me just then absolute value of y minus absolute value of y naught will be less than absolute value of y naught over 2. And this in turn will give us that minus absolute value of y naught over 2 will be less than absolute value of y minus absolute value of y naught. And this is less than absolute value of y naught over 2. Remember, this particular thing is still coming from the fact that absolute value of y minus absolute value of y naught is less or equal to absolute value of y minus y naught. And you recall that when we brought up this inequality, I emphasized that this inequality is very important and must be remembered. And you can see that we've already started applying it. And you can see the role it's playing here. Is the fact that this is less or equal to this, that I have that this is less than this. Because if this is less or equal to this and this one is less than this, then automatically this one is less than this. So please let us bear that in mind. And this particular inequality is equivalent to this particular one here, using the fact that whenever m is greater or equal to 0, then absolute value of x less or equal to m is equivalent to minus m is less or equal to x less or equal to m. We'll remember this. So now, if I go further, I will now add absolute value of y naught all through. In fact, this repetition helps a lot in clearing the ground, because I know I've done this before. I did it in the previous exercise and it came up again. So I'm sort of repeating it as a kind of emphasis in this computation, and I believe it will help a lot of people understand the computation better. So if we now add absolute value of y naught all through, I'll get, therefore, that absolute value of y naught over 2 will be less than absolute value of y, which is less than 3 absolute value of y naught all over 2. This side is also true, but the one that will give me what I'm looking for is this side, because the absolute value of y I'm controlling is in the denominator. So I need something like a constant that will come down to help me control this absolute value of y in the denominator. So what this means is that this would therefore imply that absolute value of y, that absolute value of y naught all over 2 will be less than absolute value of y, which in turn implies that, in fact, this particular one is equivalent to what I will write now, taking reciprocal of both sides. We can take reciprocal because we know that y naught is not 0 and y is not 0. So if I take reciprocal, I'll get that 1 over absolute value of y will be less than 2 over absolute value of y naught. Now, using this inequality in A, remember that this inequality is gotten provided that absolute value of y minus y naught is less than absolute value of y naught over 2. Now, using this inequality in A gives me that using it in A, we obtain from A, so I'll say thus, using this in A gives absolute value of x over y minus x naught over y naught. What it will give us is that this is equal to absolute value of x y naught minus x naught y all over absolute value of y, absolute value of y naught. But this is now less than, or rather, let me emphasize for you. This is equal to absolute value of x y naught minus x naught y all over absolute value of y naught, then times 1 over absolute value of y. But this 1 over absolute value of y, we can now control by 2 over absolute value of y. So for that reason, I can now say that this is less than absolute value of x y naught minus x naught y all over absolute value of y naught all over absolute value of y naught, then times 2 over absolute value of y naught. And this will give us 2 absolute value of x y naught minus x naught y, then all of this over absolute value of y naught all squared. Now, this here, here we observe that the absolute value, that y in the denominator has been controlled by this constant. The next thing, we shall now continue our estimate. Now, therefore, what we've gotten is that absolute value of x over y minus x naught over y naught is less than, I can write 2 over absolute value of y naught all squared, then absolute value of x y naught minus x naught y in absolute value. So we have this. Maybe I'll call this B. Now, observe that absolute value of x y naught minus x naught y is equal to absolute value of x y naught minus x naught y naught plus x naught y naught minus x naught y. I played this kind of trick before, and this is less than or equal to absolute value of y naught into x minus x naught. I can do this factorizing y naught here, then plus absolute value of x naught into y naught minus y. The same factorization, factoring out x naught. And we have this particular thing is nothing but the triangle inequality that we are using. And this is further equal to, this is absolute value of y naught, then absolute value of x minus x naught, then plus absolute value of x naught, then absolute value of y minus y naught. Remember that absolute value of y naught minus y is the same as absolute value of y minus y naught. Now, before we can, somebody may make, this is another possibility, or a kind of creating a chance for a very big error, in the sense that somebody may come at this stage and then start to say to control y minus y naught and x minus x naught in absolute value. Doing it at this stage, we put one in a serious trouble because that may not really give you what you want. That may be deceptive in the sense that you may make your estimate based on these factors here. That is the absolute value of y naught and the absolute value of x naught. And that may not really capture what one is looking for. And that is part of why I'm doing this exercise. Having brought this out separately and treated it as an entity, we must return back to where it came from before the real estimate will be done. So what am I saying? This particular thing must be placed back. We must be used in B to get the right scenario before we start making the estimate. So what I will now do is, I will say, using this estimate in B gives absolute value of x over y minus x naught over y naught. This will give us that this is less than 2 over absolute value of y naught squared, then absolute value of x y naught minus x naught y. I'm just repeating B. But with this estimate, I will now get that this will be less than or equal to 2 over absolute value of y naught squared, then into absolute value of y naught, absolute value of x minus x naught, plus absolute value of x naught, absolute value of y minus y naught. This is what I have now. That is absolute value of x over y minus x naught over y naught is less or equal to 2 over absolute value of y naught, 2 over absolute value of y naught squared into absolute value of y naught, absolute value of x minus x naught, then plus absolute value of x naught, absolute value of y minus y naught. This is what we have. And this will be equal to 2 over absolute value of y naught times absolute value of x minus x naught, then plus 2 absolute value of x naught all over absolute value of y naught all squared, then times absolute value of y minus y naught. It is at this stage that will bring in further control on absolute value of x naught, x minus x naught, and absolute value of y minus y naught. Now, if absolute value of x, if absolute value of x minus x naught is less than, watch here, this thing will help me to get the required control. So what do I want? I want this to be cancelled out, and I'll still want to retain something in epsilon here. So what I'll have is that if absolute value of this is less than epsilon absolute value of y naught over 4, say, watch out and see what this will do. And absolute value of y minus y naught is less than epsilon absolute value of y naught squared all over 4 into 1 plus absolute value of x naught. Watch here, this is where the technicality is somehow serious, and we have to be very, very careful. This manipulation is coming from what I have here, and you see what will happen when I fix it in. If this is less than this, if this control is placed, then let us see what will happen. absolute value of x over y minus x naught over y naught will be less than or equal to, sorry please, there's something, this particular inequality is actually straight, but it doesn't destroy anything because we'll still get a straight inequality. Let me correct it now that I see it. So that would be less than this, really less than that. So here, this will be, so what I have is that this will be less than 2 over absolute value of y naught times absolute value of x minus x naught, then plus 2 absolute value of x naught over absolute value of y naught all squared, then times absolute value of y minus y naught. And now, using this estimate we've just gotten here, we'll go further to get that this will be less than 2 over absolute value of y naught, then times epsilon absolute value of y naught over 4, then plus, this one will give me 2 absolute value of x naught, 2 absolute value of x naught, all over absolute value of y naught squared, then times, I have epsilon absolute value of y naught squared, all over 4 into 1 plus absolute value of x naught. 1 plus absolute value of x naught. And this would further give me, this is 2 epsilon over 4 absolute value of y naught over absolute value of y naught. I'm not worried about y naught because y naught is not 0. Therefore, absolute value of y naught is greater than 0. So this quotient makes sense. Then plus this place I have 2 epsilon over 4, then times absolute value of y naught, absolute value of y naught squared, absolute value of y naught squared, all over absolute value of y naught squared, then times absolute value of x naught, all over 1 plus absolute value of x naught. And this, of course, we see that absolute value of y naught, we cancel absolute value of y naught. Absolute value of y naught squared, we cancel absolute value of y naught squared to give us 1, 1. This 2 into itself is 1, and into this 4 is 2. This into itself is 1, into this 4 is 2. And this particular entity is, of course, less than 1. Therefore, what I have is that the whole of this will be less than epsilon over 2 from here, then plus epsilon over 2 from here, using the fact that this in circle is less than 1. So what this means, therefore, is that absolute value of x over y minus x naught over y naught will be less than epsilon over 2 plus epsilon over 2 is epsilon, provided that 1 absolute value of y minus y naught is less than absolute value of y naught over 2. This is the first condition we placed on absolute value of y minus y naught. 2, absolute value of y minus y naught is less than, if you look up here, we'll get epsilon absolute value of y naught squared all over 4 into 1 plus absolute value of x naught. So I have epsilon absolute value of y naught squared all over 4 into 1 plus absolute value of x naught. That's what we have as the second estimate or rather second control on y, absolute value of y minus y naught. Then 3, we also have that absolute value of x minus x naught must be less than what we have here, epsilon absolute value of y naught over 4. So I'll put it here, epsilon absolute value of y naught all over 4. So for this to hold, this must be the control we must put on these absolute values. And therefore, what we have is therefore, I will combine these two in one. So therefore, we have that absolute value of x over y minus x naught over y naught is less than epsilon, provided that absolute value of x minus x naught is less than epsilon absolute value of y naught over 4, and absolute value of y minus y naught is less than the minimum of absolute value of y naught over 2, and epsilon absolute value of y naught squared all over 4 into 1 plus absolute value of x naught, 4 into 1 plus absolute value of y naught. So these are the estimates we must have before we can get that this is less than epsilon. Remember, as I mentioned earlier, this estimate may not necessarily be unique. It depends on how one starts solving the problem. Depends on how one starts solving the problem. And remember also that here, I always allow a y naught to float. But whenever it comes to controlling x naught, I put plus 1, especially in the denominator. The essence of that is that if I go with absolute value of x naught without adding this 1, I'll have absolute value of x naught over absolute value of x naught, which may not necessarily be a feasible situation in the sense that x naught may turn out to be 0, and in that particular case, we'll be in trouble. Remember that at the beginning, the only thing we are given that is not 0 are y and the y naught. I think we can call it a day here. Thank you so much for listening. Hoping to see you in next lecture. And in next lecture, I'll still continue with exercises. Observe that exercises I did in this particular one are connected with absolute value functions. In the next lecture, I will do exercises that will be connected with the other topics we've talked about, such as, for instance, the issue of countable sets, what is it called, bounded subsets of R, primum and infimum. I'll do some exercises that are related to these topics. The essence of all these exercises is to help the viewer have appreciable knowledge of this course. Thank you so much for listening.